All right, sections of the crankshaft. Well, we kind of did the picture of this, but we have the main journals. How many main journals does your Lycoming crankshaft have?
4.
Ooh, you guys are really good. That was a trick question. You answered correctly. One, two, three, 4 is correct. Main journals, supported by and rotates in the main journals. We need to write that. Main journals. Sections, so that should be an I. Main journals. 1, 2, we got the crank pins. Also the throw. Also called the raw journals, aka also known as con rod journal. Con rod, which is short for connecting rod journals. All the same thing. Opposed engines. Opposed engines have 1 throw per cylinder. Have 1 throw per cylinder. So how many throws does a 6-cylinder have?
6.
How about an 8?
8.
Guys. They are numbered. Numbered in order, or the order of cylinder placement. Cylinder placement. So Lycoming. Number 1 throw is front or back? Good job. In Continental, number 1 throw is in back. What about radial engines? Can I move?
No. Yes.
Good, I heard yes. All right, I'm just going to go to my couch and lay down for a few minutes. That's why it's there. Because I would put it on Oscar's luxury seat, but he's...
First class.
What kind of bearing is that?
Ball
bearing. Done writing? This is how I can find out. You didn't hear any crying. Where was I? Oh, radial engines. Radial engines have 1 throw. Have 1 throw per row of cylinders. So how many throws would a 9-cylinder radial have?
1.
How about a 7?
1.
How about a 14?
2.
So every time it's an even number, you got to have an extra row. So that'll be 2. We also have, as I shown in the picture earlier, the crank cheek. Remember what that is? Also the crank arm. Crank arm. We have the fillet, also called the fillet. Actually pronounced fillet. and that is the radius at the end of each journal, at the end of each journal. That's an important one because when you're inspecting them, it'll often say inspect the fillet. And you're like, well, what's the fillet? And you think, well, it's probably not important because if it was, it'd be common knowledge, so I'll just skip over that part, right?
I can imagine what could go wrong.
Exactly. Well, that's only because you have bad imagination, right? All right. Caught up? Counterweights. There are really two types of counterweights. One I showed you on the radial engine where they're just fixed. Boom. Just big old counterweight to offset the weight of the single throw of the crankshaft. And then we have dynamic counterweights. This is end of a crankshaft that has been obviously cut with a torch. And you can see how thick everything is. But these are dynamic counterweights. You can see they're loose, and they're supposed to be. So inside of these keepers right here, you have a snap ring, a plate, and then there's a roller, a bar in there that allows these things to move. And they're precision-tuned, finely machined, problematic little things here. And for the most part, they work pretty well until you get humans involved. So once the human factor gets involved, then they become pretty problematic. Well, there were some problems with them not being hardened and nitrided properly. And these plates here, they're a press fit. Not by much. They're just, you put them in there and you just tap them with a little hammer and a punch and they just kind of pop in. They're not real tight. And what happened is there was some nitriding problems and there's just enough movement that these started moving. They kind of worked their way out here. And then once one of these pins come, and this crankshaft is turning very quickly inside of the engine, well, once these come undone, they start beating the crap out of the crankcase. But you know, the good news is it only does it for about a minute or two. And then it sort of self-corrects and stops working. So the other problem is how they're assembled. You know, how people are, not us, but other people. And they just look at that and go, well, how hard is that to figure out? You got a plate, you got a snap ring. You put the plate, you put the snap ring in. Well, the snap ring's got a right way to go in and a wrong way to go in. If you look at snap rings under a magnifying glass, you will note that snap rings kind of look like this. There's always a rounded edge and a very sharp edge. And the sharp edge, see in this case, the plate would go behind there, and there's a little groove that sits in, and the plate, the sharp edge, should have the force going that way for obvious reasons. So in this particular case, you'd have to look at it and know the sharp edge should be facing out, and that goes in. And then there's a space between these little snap rings. You guys probably can't see that real well. There's a space in between those. And if you don't get the snap ring in its groove all the way, then it hasn't popped out and expanded. So there's actually instructions, especially Lycoming, where they want you to pop it out and then measure the distance in there. Continental too, yeah, Continental. I think that was Continental one. And you have to measure that distance and make sure that you have enough distance. If you don't, that means that it's not there. Because once those things come apart, I mean, they really come apart well. And they fling all over the place. Over the COVID break, well, I'll get into that later. So what are they and why are they loose? Well, those are dynamic counterweights, and they're designed to take out certain vibrations. And it's funny because when you read, especially the Continental uses a lot more. Lycoming uses them, but I mean Continental, I mean they really do. Like there's some of their 6 cylinders will have 3 sets of those things, and they refer to them like, you know, they just talk about it. Well, that's the 4th order and that's the 5th order. Then you have 2, 3 orders and then another, you know, 1st order. And you're like, okay, I'm supposed to know what this is. But they label them that way, position and order. And so something that has a 1st order counterweight means it's taking out a vibration that happens every revolution. A second order is every other revolution, and a third is every third. It's all it is. But that takes out all the pressure pulses. And I think why it's so important, especially on the 6 cylinders, because the shafts are getting pretty long and they want those vibrations taken out. And I'll tell you that Continentals, I fly behind a Continental 6 cylinder, it's just remarkably smooth. But I also thought Lycomings were too. And Lycoming tends to use a lot of counterweights in their 4 cylinders. And I think they do in their 4 cylinders simply because Lycoming does in 4 cylinders what Continental usually does in 6. For example, if we take a look at the Lycoming O360 or IO360 or Lycoming, it's a 4 cylinder with giant pistons. Take a look at the Continental 360 cubic inch engine, it's a 6 cylinder. So, more power pulses, smaller cylinders, and so, anyway, just different ways of doing things. But the best demonstration, and I think it's out of your book really that talks about how that works, is that if you were to take a string with a counterweight, with a weight on the ball, and you blew on it, you would really get that thing starting to swing, right? So if you timed it just right, first order, and you blew on it every time it came back, it would be like a kid on a swing, and it would start going. But if you took and had a weight halfway up, well, that weight, and you hung another weight from below it, every time you push on that weight, this other one's going to counteract it. And so it's really not going to do much but go back and forth. So every time you blow on it, it'll go this way, the other one comes back. And I should make something like that and do it, but I can't because I wear a mask now. But anyway, and that's, I think, a great demonstration on how it's doing that. So I would just tell you that, you have to be extremely careful when you're putting counterweights together. Because if you don't, the way they set the order, well, number one, there's just so many inspections on those counterweights. There's actually it's called the bump stop area. And you can see that it actually slaps up against the crankshaft. So it's hitting right here. So you actually inspect this area down here. It can't have any wear with it. It's not supposed to slap the crankshaft. They're actually being slung out. And so it shouldn't be touching. If you actually roll it, you can feel it rolling back and forth like that. Right? And so this bump area, you inspect it, make sure there's no bumps there. There's limitations on how much damage can be there. You had a special chemical. I can't remember what it was. But you had to put this chemical inside of the holes. And if it was nitrided, it had these little dots would show up inside the chemical. It's really cool. I just don't remember what it was. And you have to measure very carefully. One of the engine manufacturers, you can change out the bushings in the counterweight. The other one, you can't. They're machined. You're put in and then machined. I hated changing the bushings because they were really pressed in hard, and I was worried about breaking something, but I never did. Yay. So when you're putting them together, you have to pay a lot of attention because the way they change the order usually is the size of the pins that go in those holes. So the bushings are all the same size, and on the crank, oh boy, did I hate changing bushings on crankshafts because they're really pressed in hard, and you just feel like you'd break one of those hanger blades, which is the part that comes out where all the bushings go in. Anyway, and so you gotta be careful because if you get the wrong rollers in the wrong hole, then you've upset the dynamic balance. The only way to fix that is to take it apart, but I assume the only way you're going to find out is because the crankshaft breaks, and so that would be really bad. So I'll tell you this story just so you can take a break. So over the COVID break, that's how I ended up getting back into aviation, was a set of those hanger blade things. This shop at Sacramento, somebody pulled up to the shop in a 182, and mechanic with a really good ear heard it making a funny tick sound. You just hear it go tick, 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 tick. Whatever it was, it just set him off. He knew something didn't sound right over the sound of the engine. And so they had pulled the mags off because magnetos can do that. They pulled some, he called me. I said, man, it's easy enough, just take off this, take off that, check that. And he's like, nah, you got to come down and check this out, Kevin. So I came down, and he said, okay, just grab the propeller, but not out at the tip, like halfway, and just pull it through. And you would pull it through, it would stop. would like catch on something. It was the weirdest thing. And then you pull it through, and then you hear a clunk. Like, oh, okay, yeah, something's going on here. And so they had already pulled off one of the cylinders so you could see one set of the hanger blades. It had 2 sets. So they kind of hypothesized it was the back set. And so they had opened up a cylinder, got to the back set, and they had pulled off one of the one of the blades. And they got to that point, and they said, and now we don't know what to do, because they'd asked me, and I said, man, I would never want to work on a set of hanger blades through a hole inside, because it's just so critical working on those things. You gotta press in the plates, and you've got to get the snap rings in just right, and you're doing it through a hole like that. And so, but they'd already took it apart, and they're like, so here's what we need you to do. Put it back together. And before you put it back together, please pull the other side off and dimension check everything. So, I'm in there with a T gauge like this, and, trying to work it. And so I got it all apart, and, and you have to measure it in multiple spots, and it's like very critical. And so anyway, long story short, I got it all measured out, and I was pretty happy with the hanger blade bushings, but the bump stops were in pretty bad shape. And what was happening, actually, I'm sorry, this wasn't the one that stopped when you pulled it through. That wouldn't make sense. It was a different plane. But the definite clunk. What was happening is the hanger blade, the bump stop was so bad that it was hanging up, and then it would hang up on itself, and then when you got to a certain point, the counterweight would fall. It wouldn't slide smoothly across the bumps. And so that's the noise he was actually hearing, which was really weird, because you shouldn't have heard it when it was running. They should have been out, but there it was. And so I changed out those back blades, but and the whole time you're doing it, like, oh, please don't drop, because you have to get all the little parts out. And I'm thinking, oh, please don't drop it, because it falls down into the sump. And I did so well until like the last thing, I dropped one of those plates, and it fell down the sump, and I spent like an hour looking for it. I had my bore scope out. I couldn't. And there finally I was like, you can't take the oil sump off because you got to pull the engine out to do it. So that wasn't an option. So, and yeah, Nathan was my buddy, he was trying to help me get it. We just couldn't find it. Finally said, well, this is what we're doing. We're draining the oil. I already did that. Couldn't find it. I said, we're going to get some fresh solvent. I'm going to pour some fresh solvent down in there and wash the oil residue out of it, and hopefully if I dump it in fast enough, it'll push that plate down to the drain, and thankfully it did, and so I was able to get it out. But that sucked, and it took like 2 hours to get that stupid plate out. But
that plate isn't magnetic, is it?
It is, yeah.
Oh, it is?
Yeah, and I had magnets down there. I was fishing, and I was just, it sucked. But, that's what you get when you're doing something that shouldn't be. So anyway, I got it all back together, and it worked. All right, so counterweights. We have also called a dynamic dampener. I should finish that story. There was more to it. So this particular 182, 182s have a belt-driven alternator off the back. And he was bringing it into the shop because it had thrown the second alternator belt. So he threw an alternator belt. They brought it in the shop, put a brand new alternator belt on. He took it out. He's flying IFR. I mean, he's in the clouds, and the thing, he gets an alternator failure and brings it back in, and it threw the belt. And so, yeah, so anyway, figuring that out, but of course, stop. I had to do all this counterweight stuff. I get it all back together. I take it out, and I run it. And I said, oh my God, this is the worst running one. I said, I don't have a lot of experience in 182s recently. I got my own, but this thing is horrible. I was shaking the aircraft like a dog passing a peach pit. So, but now this one is modified. It's a 470, but they bore the case out a little bit bigger, put 520 cylinders on it. It's a little bit of a bastard thing, but that's common. But it just shook so freaking bad. And so, I had Nathan run it, and he goes, oh my gosh, this thing runs so much better than it used to. And he calls the owner, and the owner goes, oh my gosh, it flies so much better than it used to. Like, wow, because it is still really, really bad. And so I set the alternator belt on, and and I set it, and it's tight. And Nathan came over and goes, let's make it a little bit tighter. And he really pulls back, and that belt's freaking, ping. I'm like, okay, I feel like we're going to burst a bearing on the alternator, but we agreed to that. And he takes out, he flies it 30 minutes, through an alternator belt. And when it comes in, the alternator belt's like upside down on it and stuff. It's just the weirdest damn thing. I'm like, what the hell's going on? I said, well, I think you got a harmonic balance. It's going in there that's throwing the belt right off this thing. And they kind of poo-pooed that idea, but I really felt it was it's tight, two seasoned mechanics side by side. I mean, between the two of us, we've got, 40 some years of experience on these little planes. And we both agreed that it's correct. I said it was a little bit too tight. He was happy with it, and it still threw the belt off for like the third time. And so they brought it back in again, and so then I changed all the bushings in the alternator because it was, a little sloppy. This guy's paying bucks. Takes it out. Yeah, it flew for another hour or two, and then he came back in. Guess what? But I kept saying, man, your plane is so freaking horribly rough that I don't blame it. Could you, I'd quit too. So I said, and I kept saying, you got to get this prop balanced. You got to do a balance on this thing. You got to. And finally, they took my advice and came back and said, you never believe it, but we took it to a prop balancer finally, and the prop balancer said, I can't do anything with this thing. It is so far out of balance that I'm exceeding the manufacturer's weights to do it. I can't do it. So they took the prop off and sent it to a prop shop to have it static mount. So now you're separating the engine from the prop to see which is the problem. Is it the engine or is it the prop? And they send the prop to the prop balance to a company. They said, this prop is so far out of balance, so far out of tolerance. You need a new prop. So we got a new prop, put that on, and hasn't thrown a belt since. Yeah. Dynamic damper. It's a swinging pendulum.
Is it damper or dampener?
Swinging damper.
Yeah, okay. So yeah, it said dampener.
Well, you got to go by what I write, not what I say. I also say frustrated without an R, so.
That's frustrating.
Isn't it though? And for you, for me, it's just frustrating. Dynamic swinging. Oh, I wanted to write pendulum here. Got me. Pendulum. Spelled pendulum. Okay, what are the parts involved? Parts. You've got the CW stands for counterweight. Counterweight hanger or blade. That's the part on the crankshaft that I'm passing around basically. That's the hanger weight, counterweight hanger. You have the counterweight. You have the counterweight. You have the counterweight pins or the rollers. You have the counterweight plates and the counterweight snap rings. They are used to take out torsional vibration. I have to go up. It's behind my picture at this point. Torsional vibration and power impulses. Counterweight pins, which are also, that's a parentheses, also called rollers. Rollers.
I saw that. Is there supposed to be something after the counterweight?
That is the counterweight.
Oh,
Is the counterweight. So you have the counterweight hanger, then the counterweight, and that all goes together with pins, plates, and snap rings. There's also counterweight bushings in there, but I mean, really, do I have to enable all the parts? So as my demonstration, it's like a pendulum. Pendulum hanging from a pendulum. Or a pendulum hanging from a pendulum. Is anybody caught up? Or is everybody behind? So the order order number refers to the rotation. In other words, first order is every rotation. And second order is every other rotation. And there's a service instruction, and it is lengthy. I want to say it's 20-some pages long that lists every single engine and what the bushings are and the pins are and the weight and the part number, the counterweights, and then what order they are. And it's really interesting to look through, but most of your Continentals, they're going to run 4th, 5th, and 6th order stuff. So it'll have like 2 6s, a 4, and a 5. So it's just kind of weird. I don't know how they come up. Well, engineering is how they do it. Now I'm going to tell you some stuff. I don't know how true this is. But I'll tell you what I heard. So counterweights. Oh, I believe this part. Counterweights can be detuned. And when you detune counterweights, it's very bad. It can be detuned. This is a serious event. In other words, it's not just uncomfortable for the pilot. I don't know. I'm almost glad I didn't write it down because it just becomes too much of minutia, and I don't want to bog you guys down in things you don't have to know. But it's nice when you understand something. I remember I was on a seminar one time about this company that does vibration analysis on helicopters, and it's this program that they're selling, or I don't know if it was part of the helicopter, but after every flight or every so many flights, it would data link to the company, the manufacturer, and would have all of the statistics of the vibration analysis. And so they could actually look up and say, okay, you've got a vibration at this harmonics. That means that you have a tail rotor bearing. It's this one. You've got a bearing going out in, this transmission, all this stuff. So it's something to pick up. But they also talked about how vibrations within this range you can't feel as a human. Within this range, it's like uncomfortable. Like this range, it's unbearable. And it was really kind of interesting how some of the worst vibrations are really outside of our perception. And so you don't feel them. So you may not notice a crankshaft head that's been detuned, but you can detune them. And I had some data, and it was just insane. It was in tons. I thought I had it on here. How many tons of force these, because they're roller bearings, or they're rollers, and the surface area is so infinitesimally small that it doesn't take much of a hit for tons of force to go in there, and it dents it. So you put a dent in the bushing, and a lot of times you can feel it if you hang it and you go through it, and as you do the pendulum, you can feel it drop into a little dent. You go, oh, they've been detuned. And so this is a story that, it's funny, I even mentioned it. Larry goes, I've heard that story too. But it told it at Lycoming School. And so there was an aircraft, Cessna 182-206, something like that, and down there in Pennsylvania, and they were coming in, landing on the runway, and a deer runs out in front of them, and they smash into the deer. And so what you get is it's a prop strike, and a prop strike is defined as, it used to not be defined as anything. So a prop strike, you call it what you want, but through my career, I saw it actually defined as a prop strike is anything that requires the propeller to be removed for repair. Then that is a prop strike, and the engine must then be completely disassembled, inspected, repaired, put back together. Not overhauled, but prop strike inspection, which is what I did majority of my career, I would say. Anyway, so as is common, It damages the propeller really bad. They park the airplane, they send the prop out, get a brand new prop, borrow a prop, whatever, bolt it on the front of the engine, call the FAA, do the appropriate paperwork. It's called a ferry permit. We used to do it all the time. Say, okay, we've got, which doesn't make sense, does it? We've got an aircraft that's had a prop strike. The engine is questionably airworthy. We don't know. We can't work on it here. We're just going to fly it to this airport. And so this flight that they took this Cessna on was, I want to say it was in the neighborhood of the story of 5 to 10 minutes away. It was just a quick, and so everything checked out. To get a ferry permit, you make sure everything, you have a mechanic look at it, so everything appears to be sound, put the propeller back on. They, the FAA signs off the paperwork. It's one flight, boom, they land, and as they landed and stopped, they noticed that the engine looks just really bizarre as it came to a rest, and they were, what the hell's going on? And as they pulled the cowlings off to get to the engine to take it out, the way big Continentals are, it's not like your Lycoming has 4 holes in the back of the case, and so it's got the motor mounts come up this way and this way. Well, a Continental has a bed that goes way out, and then it's got 4 legs, 1, 2, 3, 4 on this bed that goes out. And so you have these little legs that come out. Every one of those legs, they said it looked like a laser had cut through it perfectly. Every single one. There was nothing left holding the engine in but the cables and wires. Wow. And the cowling itself. And it wasn't like that 10 minutes ago. So it's not that they broke from the prop strike. It broke from the vibration of the detuned counterweights. So... yeah. So detuning. So serious event. So 1, I told you the deer story. Okay. 2, and the guy who told me, he swore, I mean, it's true. He was not joking. And like I said, Larry had heard the same story. I'm like, yeah, I heard that story. He goes, yeah, I did. So detune happens when a flat spot is created in the bushing, roller, or both. Okay, here's the part where I'm like, yeah, I'm not totally convinced on all of these things, but I'm going to tell you. Detune can happen by, and by the way, that the teacher that I had for the Lycoming school, I would venture to say he's no longer on this earth because he was a very elderly gentleman, and he had spent his entire career in aviation. I think his daddy had spent his entire career in aviation. So, the guy had definitely been around and knew what was going on. Quick throttle changes. If you fly with me, and I hope some of you do, I love giving people rides, you will notice that I'm very ginger with my throttle. As I take the center line and I'm about to take off, I'll take the center line, and it takes me, especially here at 10,000 feet of runway, I'm in no hurry. I move that throttle pretty slow. 2 reasons. Number 1, especially if my engine's a little cold, my engine will overspeed because the cold oil takes time to go through the governor, through the propeller transfer collar, out into the propeller for the propeller to hold me off a red line. So I've watched it with the handheld tack check digital and watched it. And so like in low dive where I take off on a shorter field, I gotta be a little faster. It'll go 24, 25, like 24, 50, about 50 RPM high and then back in. I don't want that. That's my major concern, but they say quick throttle changes can detune. I just don't quite buy into that. You'd have to be changing it pretty fast, and I just don't know, but that's what he said. This one I really have my doubts. Letting the prop run the engine. I seriously have my doubts about that. By that, I'm saying that if I pull my throttle all the way back and kind of dive at the ground, a high airspeed, well, the prop is driving the engine. this is my thought. Can't imagine it. Why would it detune the counterweights? They're not being abused or bumped. Granted, they're not taking the impulses that they would normally do in a high running engine, but they are spread out because of centrifugal force and doing what they're supposed to do. So I don't know why it would detune it. I have heard that this, I want to be careful. They used to call it a wives' tale, but what's a better way to put that? Legend. There we go. There's a legend that some of the older radial engines of the World War II vintage had particular parts that could be damaged by doing that. And I think that had more to do with maybe some of the planetary gears and the various other things. Have you heard that too or something? Or you guys are nodding like you agree with me.
We were trying to figure out other words for you, so we came
Is
up
that
with
legend, myth, fable?
There we go, yes.
fiction,
Fairy tale?
not true.
Twilight
Might be
Princess
beer.
story.
Feathering at high RPM. Okay, that I can kind of buy into because if you spend any time at an airport, watching and listening to airplanes, especially only an aircraft with a constant speed prop, part of your run-up procedure, and I only do it for the first run-up of the day, is as you prepare to take off, you do an engine run-up. And so I'm going to bring my aircraft up to 1700 RPM, and I'm going to turn off one of my ignition to make sure it runs on. So I'll turn off the right, make sure the left runs it. Then I'll go back to both and turn the other way, make sure the left is running. Otherwise, how do you know? One could be completely dead, but the engine goes. So you got to turn each one off, verify it. Then I pull my carburetor heat, make sure the carburetor heat flap is working, and I should see a noticeable reduction in RPM because hot air is now going into my carburetor, which is down here. And that hot air is less dense, so the volumetric efficiency technically has decreased. So I have less power, so I see a noticeable loss of that at 100, 200 RPM. Okay, that's working. Put that back on. Then I grab my propeller control and I pull it all the way out. And when it's cold, it takes a second, like, ooh, that's not doing anything. And then suddenly there's a high inrush of, depending on the engine, could be a high inrush or outrush of oil, which is going to rapidly go from a high RPM flat blade to a very coarse pitch. And you hear that when people are doing it. And it kind of sounds like, yeah, they threw something into the prop. It almost sounds like they just ran into a tall grass or something. Like if you had a lawnmower and you're holding it up and just dropped it into tall grass, it sounds just like that. And you just hear that engine just bog down. And some people, you just hear it. I mean, they're up there 1700 RPM. It's, and it's just struggling. And you're going, damn. And then, of course, they put it back in and comes back up to normal. They do it 2 more times, Yeah. So you'll hear me. So I pull mine all the way out, and the minute I sense that it's starting to go, all the way in as fast as I can. So it's just a very quick and sudden change. It barely changes. I don't want more than a couple inches of manifold to change on that because it's not good for them. So, and of course, so I do believe in this one, definitely. Which is kind of, I guess that would go along with quick throttle changes. That would be fast RPM changes, which is the same thing as feathering and high RPM. Oh, by the way, feathering is not just pulling it. Feathering is when the blades go this way, all the way. They go from high RPM to 0 RPM. So in a twin engine aircraft, if you lose an engine, you don't want it windmilling out there, especially let's say it had a dynamic disassembly because somebody messed up the counterweights. So it's just coming apart on itself and shaking. You got to shut it down. You don't want it spinning at all. So the blades go into a feather on twins, and it decreases the drag and stops that engine from windmilling. So if you were at high RPM and you pull the the prop all the way back and go up over the gate and back in, it goes from high RPM to low RPM to feather. And that's okay if you have a turbine, not a turbocharged, a turbine.
I was gonna say you hear that a lot, like when like a turboprop comes in, parks in a spot.
Oh yeah.
They'll completely feather out.
Yep.
Now, obviously, there isn't an issue there because it's not. Well, I guess it's connected, but it isn't. It's not in the same way as a reciprocating engine. Right?
Yes, they have an opposite problem. If they didn't do that and it sat there and motored, it doesn't have oil pressure.
Why is that?
Uh,
Well, I
be-
guess we're not in that class. We don't
No,
know.
no, he's going to tell you. Because you may have a free turbine, and so you have a power section is connected to the oil pump, and this section is only connected by air. And so when you lose that air pressure, this shut down, and it's actually not spinning, but this is still spinning, but the oil pump isn't. So that's bad on them. So they feather instantly. So whoosh, and you just go, okay. But that's okay with the turbine. You want that. Not so much with the piston. You don't ever want to do that, and it's really hard to start a piston engine when it's been feathered. If we have time in the next class, we'll run the 310 or the Skymasters, which are twins, so they'll feather. And I usually will feather out the if it's starting well and running nice out of fuel. I'll feather the 310 on us. Show it to you, and then I got to restart it, and sometimes it works and sometimes it doesn't. And it's funny when you do get it restarted, man, it just shakes so bad because it's not meant to do that. And then it starts to smooth out, and you hear the prop go into a high pitch and a high RPM. You're like, oh, okay, this will work. And of course, definitely prop strike. Without a doubt, you prop strike also called sudden stoppage. You know, you run up the back of a car with your airplane. It will do that. Oh, here it is. A sudden deceleration. Puts about 90 tons of force on the bushings. And that's right out of Service Bulletin 245. That's a Lycoming one then. They're also may be used in radial engines. Oops. Engines, I don't know. I don't have one. Oh, actually, see, this is like here, and this is out. That one's out here.
Ah.
Yeah, I know, because I went way back out. So maybe use radial engines. They could be dynamic or static counterweights. Could go either way. And I guess that's probably a good place to stop because tomorrow we'll start talking about prop shafts. So that's a good place right there.